Okay, so we've got a board full of gems. Now we need to start moving them around in our game. So let's go open up our gems script. So if I go to my script folder and open my gems, and we're going to add in a few variables that we're going to want to use. Now, for us to be able to keep track of to be able to do our movement, what we're going to have is we'll touch the screen with either your finger or your mouse, and then you'll swipe in a particular direction. So if I go back in here for a second, say we've got our red gem here. If I swipe to the right, we want to know that we're swiping to the right, and we want to swipe in all these different directions here. So to do that, if I just open the little diagram here, let's imagine we have our grid of our gems, and we have one gem here and we have another one here. We want to swap these two around. So we start this one here and we swipe in this direction. We need to know two things. We need to know where we started doing our swipe and where we ended our swipe. And then we can use a bit of maths in Unity to calculate what direction this is in. And this is going to give us an angle basically that we can use. So it'll say if we're going to the right, the angle, if we're going exactly right, the angle will be 0. If we were going exactly up, the angle would be 90. If we're going exactly down, it'll be minus 90. And exactly to the left will be 180. So we want to calculate the amount of movement that's happening, and then we'll know which direction we're facing. So to do that, let's go back into our script. We're going to need to know those points where we start touching and where we end touching. So we're going to create a private vector2 that we'll call first touch position, and we'll create another private vector2 that we'll call final touch position. Then we're going to have a private bool called mouse pressed, and this is how we're going to know if we're currently holding down, so we know when to let go. And then we're going to have a private float that we're going to call swipe angle. I'm going to set that to be 0 by default, and this is going to be the angle that we have or the angle that we'll get to know which direction we're swiping. So we'll know if we're at 0, if we're at 90, 180 or 90. Now obviously what happens if we swipe slightly up this way? We'd still really want to count that as a swipe to the right, but say maybe that's 10, that ends up being 10 degrees. So we'll want to say anything kind of in this range, so between 45 and minus 45 should count as a swipe to the right. Anything up here, so going up to 135, will count as a swipe up, and so on. We'll do the same thing in all the directions. We'll come back to this in a moment when we're calculating that. But first thing we need to do is determine how do we get our touch points. Well, how we can get the first touch point is really easy. All we're going to do is scroll down to the bottom here. We're going to add a function called onMouseDown. So if I start typing onMouseDown, we'll actually get this as an autocomplete. So onMouseDown is a function built into Unity, which basically detects when we press on an object. And to test this out, we can do a debug.log. I'm just going to do pressed dash, and I'm just going to say plus the name of this object, because we know we've given each one of these a special name. Just to demonstrate this, so one important thing to know about the onMouseDown is if we just let this compile and run, it won't magically know that we've pressed something. Oh, no, it hadn't finished loading. There we go. Oh, I still had the game running. That was the problem there. I was wondering what was... It's waiting now to compile things. I got a slight warning down here for the swipe angle not being used, but that's because we haven't set anything up with it just yet. Everything is running very slow for a moment. It'll catch up with itself in a second, I think. There we go. I don't know what was going on there. So if I click on one of these now, we don't get our little debug message coming up, because Unity doesn't necessarily know that these are objects that should be clicked on. How we can make them something to click on is if we go to our gem prefab, I'll go to our blue gem here. I'm going to double click this just to open it up as something we can reference. I'm going to go over here and I'm going to add component. I'm going to add a box collider 2D to this. So I start typing box there and it automatically started to find the thing I want. But if you want to manually find it, you can go here to physics 2D, and here you'll see a box collider 2D, and this will add a physical object to our physical component to our object. You can see it now has this green outline around it, and that's the box area that we can click on basically. So I'm going to make the size of this box collider be 0.95, so a little bit less than 1, but a little bit bigger than the image itself, and that's perfectly fine. So now that we know we can click on this individual one, so now if I go back and play, because we know we've made this change to our prefab and that applies to these other variants as well. If I go and play, now when I click, there we go, it says I pressed gem 4.3, and each individual one, you can see I'm getting the click appearing. So now that we know that we can click on each individual gem, we can remove this debug log because we don't need that anymore, and we can just say our first touch position, and we need to know where our mouse is in the world. So we can use something called the input mouse position. But if I do that, so if I do input.mouse position, if I just save this, and again I'm just going to debug this just so we can see it a bit better. Debug.log input.mouse position. You'll see this is going to be the way it gets the input.mouse position is going to be a little bit different. So if I click on it here now in our console down the bottom left, you'll see it's got 636 and 217. So these numbers are obviously really high, and what that's actually telling us is the mouse position relative to the full size of the screen. So this is, I've got this set up as a 1080p screen here. So whenever I click on these, it's telling us, hey, you're at pixel 600 to the right and pixel 200 up. So that's obviously not great. So we want to convert that into the world space so we can actually tell which one we're clicking on a little bit better. So let's go back in here, and what we're going to do is, instead of saying input.position, we're going to say, right before that, we're going to say on our camera, our main camera, so camera.main. So you want to know what the main camera is, so basically the camera that we're using in our scene. And we're going to call the function screen to world point. And then we tell it we want to convert, we're basically saying convert the mouse position into a position in the world based on the camera that we have. Now, one thing I just want to say here, we're using camera.main, and camera.main basically is a way to check and find the main camera in our scene. And you might have heard previously that camera.main is really bad to use over and over again, and that you should store the camera.main to something else. And that used to apply in Unity, but they've actually changed it kind of behind the scenes in Unity. So the very first time that you call camera.main, it actually gets stored behind the scenes in memory of Unity. So that every other time you try to call it, it used to be a thing that it would use up a load of resources trying to find the camera every single time, but now it only uses those resources that one time, and it immediately makes it much easier to find. So if you've seen before not to use this, it's 100% okay to use now. Unity changes so it makes a lot more sense to use. Just a minor little thing to throw in there. But now if I go back into Unity and let that compile, or it is compiled, and if I click on here, oh, did I not save? Oh, I didn't save it. Well, that doesn't help. So let's stop that. Let that go there. There we go. And now when I play, if I click on it, did I remove the debug? Of course I removed the debug, so it's not going to actually show me much if I have the debug gone, is it? Let's do, I'm just going to quickly type this again, camera.main.screen to world point, nice and simple, and then I'm going to make this tell us what the first touch position is. So try this one more time, and now when we play and I click on 1, there we go. So it's got 3.8 and 1. So it's much more sensible now. We've got our 0, 0, and we've got 1, 0, and basically 2, 0, and so on. So perfect. And we now have a more accurate position in the world. And now that we've pressed the mouse down, we don't need a debug log anymore, but we do want to make sure that when we press it, we say mouse pressed equals true. And now that we know the mouse is pressed, if we go into update up here, we're going to say if mouse pressed is true. So if we're checking to see if we are already in a position where the mouse has been pressed, and input dot get mouse button up. So we want to say, hey, when the mouse button is released, and we have to tell it which button is being released, and we say 0. So 0 refers to the left click of the mouse. So basically we're saying if the mouse has been pressed and we let go of the mouse button, then we're going to say our final touch position will be equal to, again, camera dot main dot screen to world point input dot mouse position. So now we have the first touch and we have the final touch, and now we need to work out what the angle is that we're going to use. So I'm going to add a new function down here, a private void calculate angle, and we're going to call that in here. So whenever we let go of the mouse, we're going to say, okay, calculate the angle that our swipe is happening in. And then in our calculate angle function, we're going to say we want to set our swipe angle. So our swipe angle that we have here, we're going to set that to be equal to, we're going to use a maths function built into Unity, and what we're going to use is mathf dot atan. Sorry, atan 2. So if I hover over this, you see it returns the angle in radians whose tan is blah blah blah. And what it needs to take in some values. It needs a y value and an x value to give us a angle, basically. So how we calculate the angle is we take our final touch position dot y and take away the first touch position dot y, and then we take our final touch position dot x and take away the first touch position dot x. And that's going to give us an angle for us to use. So I'm going to say debug.log the swipe angle so we can see this in action a bit better. I'm going to save this and let's go back in here, and then let's pop out our console so we can see it a bit better. I'll wait till the game is running. I do a little swipe and pop this. Okay, well, it's not letting me pop it out very well. Let's just get it over here. There we go. So if I do a swipe, you can see, well, that gave us a good number there. If I swipe to the left, it's given us a number of 3.12. If I swipe up, let's get this one. Swipe it up. Let's get a 1.45. So you'll see the numbers that we're getting are not necessarily the numbers that we want. So what we're getting is, well, a couple of things are happening here. When I'm swiping to the left, we're getting a whole bunch of numbers appearing here, and it's updating a whole load of things, and that's because of one thing we forgot to add in, and we'll go back to that in a second. But most importantly, it's given us numbers that aren't really logical for angles, because what it's returning is radians. So these are numbers basically between 0 and pi are the numbers that it's giving us. So we don't want that. So let's just dock my console again. And let's go back in here. So first thing is that we never set it so that mouse pressed would be false. So basically what's happening is when we press on mouse down and that's been marked as true, then it goes up to here and says, okay, that was true, and now we release and it calculates the angle, and this kind of gets caught and happens a few times. So we don't want that to happen. So we say as soon as we enter this section, we say mouse pressed equals false. So we've no longer pressed the mouse at this point. And then let's go back in here and just run this again so we can actually see the numbers appearing a little bit better. So if I swipe that, oops, I'm trying to get this to pop out. Sometimes Unity likes to grab and dock things a lot more than we want. But now if I swipe to the left here, it's not picking up any of the... Oh, it's just not showing them in this console for some reason. There we go. Now it's updating them. It was updating down in the bottom left. So if I swipe to the right, it's just above 0. If I swipe all the way to the left, it's just around 3. So we want to convert that back to normal degrees for us to be able to understand it a little bit better. And how we can do that is go down to here, and we take the result of this mathf.atan. That's what's stored in our swipe angle. And now we're going to say swipe angle is equal to whatever our swipe angle currently is, multiplied by 180 and divided by mathf.pi. So mathf.pi is just simply the 3.14 blah 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 blah. So we're dividing that number that we have here by that and multiplying it by 180, and that'll give us then, when we go back in here, if we let this play, if I swipe to the right, you can see it's just above 0 just because it's very close. But if I swipe to the left, this time it's just under 180. If I just go a little bit higher, it's just above 180. Or sorry, still just under 180. And if I go up, you can see it's about 80. So it's given us logical numbers now. So now we have an angle that we can use to establish which way our gems should actually move in our game.